morning, class. Today we're going to look at some coefficient calculations for waveform 9. Here's the graph of waveform 9. We have a 0 half cycle. The first half cycle is characterized by a straight line with a slope of 2v max out over capital T, and of course an intercept of 0. So we had already developed the equations for that waveform in our previous lecture. Now, one thing to note is that this waveform has no symmetry. And so this means we have no shortcuts in our Fourier analysis. In fact, it specifically means that we would have to perform all of these integral calculations, A0, AN, BN, and furthermore, the series we can expect would be of this form. We can expect the constant term out front. We can expect non-zero cosine terms, in fact, an infinite number of them, and we can expect an infinite number of non-zero sine terms. So I thought that today, rather than developing this entire series, what I'll do is take you through the calculation of 3 very specific coefficients. So we're going to use each formula, but I selected the following. Let's calculate that DC component. Let's calculate one specific AN value, and I chose A3. Let's calculate one specific BN value, and here I chose B4. In fact, when I give you an assignment for this unit, this is the kind of thing you'll be doing, is calculating very specific coefficients rather than developing the entire Fourier series. Okay, let's begin with our calculation for A0. The formulas can be found either on this page here. They're also on the top of this page here. Okay, so I'm going to start with the A0 calculation. So here is our A0 formula. Now, when we substitute V at T, we will be substituting this, and we're going to be adjusting our limits as well, such that the top limit is just capital T over 2. The second half cycle is 0, so it will not be included in our integral. Okay, so just as I said, we've got 0, capital T over 2, and in place of V at T, I have put in this expression. Okay, now these are constants here, so I'm going to push them in front of the integral sign now. The only thing here to integrate is T. We're integrating with respect to T. Don't forget, this is like integrating T to the 1. So we should get 1/2 T squared, like this. Okay. So I simplified the constant further. In other words, I did this to give me V max over capital T squared as the constant. And now we're ready to go. Here, where the T is, we substitute upper limit minus lower limit. And that looks like that. When you square this, you get T squared over 4, okay, minus the lower limit. And then in this last step, we get our final answer, V max over 4. So the value of A0 is V max over 4. Okay, let's go on to calculate A3. Now, of course, that's going to demand a different formula. We used the A0 formula, now we're going to use the AN formula. Okay, so there it is. That's the AN formula. Again, the very first thing we do is substitute our equation for V at t. We'll also be changing this upper limit to capital T over 2. Again, the second half cycle is 0. And this is what we get. Okay, I'm going to move the constant forward, so you'll see it forward in the next step like that. Okay, so the constant is now 4v max over capital T squared. This integral can be found on your formula sheet. Make sure you choose the one that has the t in front of the cosine term. That's here. So in place of that integral now, we'll put in this. Okay, there it is. A reminder of our limits here at the end. Clean up your constant out front. Okay, so I can see here t squared will cancel this t squared. 2 squared will cancel this 4. So the constant out front is now V max over n squared pi squared. All right, this part did not change. It's exactly the same, but now it is time to do upper limit substituted first. And of course, we substituted it everywhere there is a t. So here and here and here it will be substituted. Okay? Then a subtraction sign. And wherever there is a t, we'll be putting a 0. So here and here and here. Okay, notice the bracket, because it's a binomial. A bracket, again, it's a binomial. So I took capital T over 2, I put it here, that made the angle n pi. I put it here, that made the constant n pi. Here, the angle is n pi. Subtraction in between. In goes the 0, making the angle 0. The 0 here gives me the whole term equal to 0. And then I look at this expression to see what can be evaluated. Certainly the cosine of 0 is 1. The sine of any integer multiple of pi is 0. Right? The sine of 1 pi is 0. The sine of 2 pi is 0. And so on. This cannot be evaluated yet because sometimes the cosine of n pi is 1 and sometimes the cosine of n pi is negative 1. Okay, so again, here's this sine wave. The sine of pi is 0. The sine of 2 pi is 0. Okay, the sine of n pi is 0 for all n integers. But here's cosine. When you have 1 pi, the cosine value is negative 1. But if you have 2 pi, the cosine of n pi is positive 1. The cosine of n pi is 1 when n is an even integer. It is negative 1 when n is an odd integer. So we cannot substitute a value here. So in my next step, you'll see this term is gone completely because it's n pi times 0, and you'll see a 1 here. So this is all we have. This term minus 1. Okay, now if I was going to develop the whole Fourier series, this is when I'd have to break the solution into two based upon whether n is odd or n is even. However, remember, we set out to calculate only A3. A3. So this is when we substitute 3. So A3 would have a 3 in this spot and a 3 in this spot. And then you can evaluate this. You can use your calculator to work out the cosine of 3 pi. If you like calculator in radians, I think it would be safe to put a bracket around 3 pi, cosine of 3 pi. Or, of course, you can remember what the graph looks like. The cosine of 3 pi would be down here, and it's equal to -1. So we end up with -2 in the brackets. And that means our final answer for A3 is -2 Vmax over, now it's 3 squared pi squared, or 9 pi squared. Okay, so that was a calculation of A3 for waveform 9. And let's also do the calculation of B4. There'll be a lot of similarities, okay? But the first thing to ensure is that we're using the correct formula. We need to use the BN formula when we're calculating B4, okay? This guy. So, substitute our specific V at t, change this to capital T over 2. Again, because if you wanted, the second piece would say plus the integral from t over 2 to t of 0 with respect to t, right? So that whole second piece is 0. So here's what it should look like. Okay, so just like the last one, push the constant forward. Recognize that this is on our formula sheets. This one right here. So in place of this integral, we put in this expression. Don't forget to indicate your limits at the end. Time to clean up this constant. Again, we will be able to cancel both t squared and 4 from numerator and denominator. And that looks like this. Substitution of the upper limit. Put the two terms in a bracket. There'll be subtraction in between. Then you can substitute the lower limit, again, putting the two terms in a bracket. Okay, so see, a bracket around what we get when we substitute capital T over 2. A bracket around what we get when we substitute 0. Okay, so substitution of capital T over 2 will give us n pi for the angle, n pi for the constant, n pi for the angle. So it looks just like that. Substitution of 0. We'll get the sine of 0 minus 0. Let's evaluate what we can. The sine of 0 is 0. The sine of n pi is 0. Again, this is true whether n is odd or even. The sine of pi is equal to the sine of 2 pi, which is equal to 0. So we can state this and this. Conclusively, this is the only term left, therefore, like that. So what I did, since I had in here an n pi and down here the square of n pi, I reduced that constant. Okay, so only cosine n pi is left here, and I canceled an n and I canceled a pi, giving me this out front. And here's where this quantity has two different values. Sometimes it's 1, sometimes it's -1. So if we were going to develop the whole Fourier series, we would have to split our calculation into those two cases now. However, we set out to calculate only B4. So this is the point at which we will write B4 equals, and we will substitute 4 here and 4 here. Like that. Okay, the cosine of 4 pi, this is equal to 1. You can put it into your calculator to work that out, or again, you can use your graph along with the summary here. So substitution of 1 there gives us our final result. The value of B4 is negative V max over 4 pi. Okay, I hope that you were able to follow that lesson okay today. And as I say, on your major assignment that you'll be doing for the course, this is the kind of thing you're going to be asked to do. You'll be calculating A0 possibly, and then specific values of AN and BN. Okay, guys, have a great day.